Okay, this view is also important for anatomical terms. I want to draw in the midline. The midline is, as the name implies, the line that runs right down your middle. Now, if you want to refer to something being close to the midline, you say it's medial, and I'll indicate medial by drawing arrows toward the midline. Now, on the opposite, if you want to talk about something away from midline, towards the edges, towards the sides, going away from midline, that's lateral. Many functions in the nervous system cross sides, motor functions, for example. So, in that situation, when you're going from one side, crossing midline, and going to the other side, that's contralateral. If you want to say something is on the same side, so it starts on that side and stays on that side, then you say it's ipsi or same lateral, same sided or opposite side. The next view that's important to us is this view, just a lateral view of the brain. Now, when you do this, we can vaguely chop the brain into thirds. Ugh, excuse me, guys. We can chop the brain into thirds. And when you do that, this is the superior, middle, and inferior. So we can do this for the overall brain. And as you'll see in more clear detail later, we can also do this same thing in the frontal lobe. And you call that superior, middle, and inferior. And then, as again I'll show you later in much clearer detail, we can chop the temporal lobe into thirds. Again, superior, middle, and inferior. Now, the brain is, of course, a three-dimensional object, but it's extremely difficult, at least for humans, to communicate and visualize in three dimensions, especially if you want rich detail. So, the brain is usually studied in slices. You have a three-dimensional object. You're going to have X, Y, and the Z plane coming out at us. Now you can slice the brain along any of those planes. And when you do, you see that you get extremely different views of the same organ. When I was first learning the brain, this was actually overwhelming, the complexity, because you really do have to study eventually if you want to continue the brain in all three dimensions and then mentally reconstruct it in a way. And that happens after years and years of dealing with the material. But at this point, you have to learn the names of the slices, of the two-dimensional slices, and know what can and cannot be seen in each of the slices. Plus, a little bit frustratingly, the slices have, at least two of them, have two different names. So let's go through them. We could take slices of our brain along this plane. When you take slices like so, they look like this. So the text author calls this the transverse plane. This is mostly the terms used in animal research. In human research, usually we call this coronal, the coronal plane. Both are correct, and you do need to know both. Now, what can you see in a coronal slice? Well, where are the ears, for example? Just let's draw the ears so you have a little bit of perspective. So you can see all the way from left to right hemisphere. So left to right, right to left. Check. You can see dorsal to ventral. Check. What you cannot see is AP, anterior to posterior, or uh, rostral to caudal. Okay, so that's coronal or transverse. Let me clear this so we can do the same for the next plane. Another way you could slice the brain is along the long axis. So if you were to imagine a blade, hold the blade right up to your face, the blade uh, pointing up, and the handle of the blade around your chin. This is the plane we're talking about. If you move the blade up and place it on top of your head in the same plane, you might get a better visualization of the plane. That's called the sagittal plane. Sagittal. And this is the only name. This is a special sagittal slice. This is the mid sagittal slice. It's special because it's literally down the midline. So sagittal. Let's talk about what you can and cannot see in sagittal. Okay, left to right. Oops, nope, not in a sagittal plane. In a sagittal plane, you could visualize the eyes, but the ears are not in this plane. All right. Can you see? I think next we did dorsal to ventral. Dorsal to ventral. Yep. There's the dorsal, right? And here's the ventral. Check. Can you see rostral to caudal? Yep. Or what did I think I used both. Yes. Okay, let me clear this. The last plane is to put a blade uh, sort of by your ear where the handle is You're holding the handle sort of right next to your cheek, and the point of the blade is at the back of your head horizontally. So we're taking slices like it's not as easy as it looks with these tablet things. So we're taking slices like this, but straight. The text author calls that the horizontal plane. It's also known as the axial. So what can you see? What can't you see in axial? Let's draw the ears. You would be looking at the top of the ear. So how can we draw that? Sort of something vaguely like that. Top of the ear here. Where's the eyes? The eyes are here. Nose, the rostrum, right there. Okay, so what can you see? Can you see left to right hemisphere? You sure can. You can see both ears, can't you? Dorsal to ventral, however, we cannot see. Dorsal to ventral, we cannot. We don't have the information in these two dimensions. The dorsal ventral is gone. And we do have anterior to posterior. Anterior, anterior posterior, and rostral to caudal, same thing. So we have that. Now, when you look at the spinal cord, if you hadn't followed my recommendation to study dorsal ventral in this position, this is confusing because look at this slice here. What is it called? Transverse. So what slice is this in the other terminology? Coronal. So how is this plane the same as this? Well, you have to imagine the person on all fours. Then it begins to make sense. So if the spinal cord is going back here, as it would if you were on all fours, okay, can you mentally translate this? And you would see that it is this slice, and indeed, this plane and this plane are the same. It just, this is drawn on an upright human, which is downright confusing. And those are the anatomical terms and the names for the planes and what you can and cannot see in the planes.